Hello and welcome guys. In the last video we have completed this visualization on chunks of audio. So if you are new to this video, then please watch this playlist from beginning. So what we have done so far, first we have seen the visualization of single audio, and then we have chunked those audio files in 4 seconds, and then we have seen the visualization. So why we are doing here chunking? Because it's very hard to represent all the feature of this entire 30-second audio in one graph. So what we are doing, we are splitting those audio signal into 4 seconds by taking a overlap of 2 seconds, and we are representing that 4-second audio separately. Okay, so by doing this, like as compared to this 30-second audio, we can represent this 4-second audio file in graph, and we can extract the feature from it by plotting the Melspectrogram, and then it's easy for our model to take the important feature and understand the pattern and understand the what is exactly how it is different from other audio signal. It's easy in this 4-second audio, but in this 30-second audio there are too many things, like a lot of things are there. So it's very hard for our model. If later if we are going to build a Melspectrogram on the top of it, then it's very hard for our model to grasp the important feature from it. So what we are going to do, we are going to split those audio into 4 seconds by taking 2-second overlap, and we are going to plot Melspectrogram on the top of it, and we are going to use this thing. So before starting that, let me show you first how Melspectrogram of this 4-second audio exactly looks like. Like we will plot Melspectrogram for this entire audio, for this entire 30-second audio. Also we will plot Melspectrogram for this 4-second audio. Then we will see the difference between that. So this is what we are going to do in this video. Let me give here markdown first. Give here 2 hashes, Melspectrogram visualization. Okay, let me create some more cell. Press escape B to create more cells. Okay, so first what I will do, I will create function to make Melspectrogram for this entire 30-second audio. Okay, first we will do this thing. So let's give here comment as Melspectrogram of entire audio. So here I will define one function, plot Melspectrogram, and in this I will pass y and sampling rate, which we are loading. Once we are loading our audio file using Librosa, then we are getting this y and sampling rate. We will pass this to this function, and so what this function will do, first we will calculate the Melspectrogram. Spectrogram I am writing here. So to calculate Melspectrogram, I will use Librosa dot feature. I will use, if I give here dot feature, and inside this I will use this Melspectrogram function. Okay, and inside this what I will pass, I will pass y, and sampling rate I will pass sampling rate. In the second video of this playlist I have discussed in detail about the Librosa API, so you can watch that to understand that how we are writing this. Okay, so this Librosa.feature.Melspectrogram function has 2 parameters, so we are passing this y and sampling rate here. Okay, so what it will do, by doing this we will compute Melspectrogram. Okay, compute spectrogram, not Melspectrogram. So this thing will compute spectrogram. Okay, now what we will do, now we will calculate the Mel scale. As I already showed you in the Melspectrogram introduction, that after calculating spectrogram, once we modify that y-axis, then that spectrogram will get converted into Melspectrogram. So for that what we are going to do, so let's comment here convert to decibels. So let's write here convert to decibels, and in bracket I am giving log scale. So we are converting into log scale. So what we are going to do, let's give here one variable spectrogram dB. Okay, decibels, in decibels we are going to convert. So I am writing here Librosa dot power 2 dB is one function, Librosa dot power 2 dB, and this function will take this spectrogram which we have got from previous. So this spectrogram it will take, and second argument will give ref will give, and this is np dot max we will give here. So exactly what it is, let me go to this API and show you. So if you go here, so this librosa.power2db, what it will do, convert a power spectrogram which we have which we got from here. This librosa.feature.melspectrogram will give us spectrogram, which is power spectrogram. We are converting that power spectrogram to decibel dB units, and it takes two parameter. First is your spectrogram, and second one is this ref, which is, it is if scalar, the amplitude, its absolute value it will calculate is scaled relative to ref. Okay, so here we can give lots of things like np dot max or other things you can give here by seeing this, like here it's giving these things, threshold and all. So here I am what I am giving, like here they have showed that you can give like this also. Okay, so compute dB relative to peak power. So here what we are going to do, here we are giving np dot max. Okay, so it will convert this to decibel, to log scale. Now we want to visualize these things. Okay, so this part here we are going to do a visualize the spectrogram. We got our spectrogram, and then we also got our y-axis from here. Okay, this is basically our Mel scale. This will put in y-axis of our graph. Okay, so what we are going to do here, plt, this is matplotlib part which we have imported here. Okay, so plt dot figure, first we have to define some figure. So fixed size I am giving here, fixed size I am giving as 10,4. this fixed size I have checked, and this is on this fixed size I am getting good result, that's why I have chosen this. And then what I am going to do, I am going to use this librosa.display to plot our Melspectrogram, and display I am going to use spec show. This also I have talked in detail in my second video, and this spec show will take, what it will take is, it will take y-axis as this thing which we have calculated here. This is our Mel scale, this is our y-axis, and second thing it will take a sampling rate which is SR. Okay, and then what it will take, we have to give here x-axis it will take as time. Okay, and y-axis we will write here, y-axis will write here Mel. Okay, this is our Mel scale. Okay, so this is what it will take. Now we will write here plt dot color bar we will give, and color bar we will pass some format. This is also a part of matplotlib, so if you don't know about this, then go to matplotlib documentation and you can get color bar and how to pass this format. Okay, and here what we are going to pass, here we are going to pass percent and 2.0, this is a floating point number, and then we are going to write here dB, and that's it. This thing we are passing. Okay, it will show the color bar, so that like from what values to what values, like it will show the color. I will show you when we display the result. Plt dot title will pass, plt dot title I am passing, and in title I am writing as spectrogram, or you can write Melspectrogram, anything. Okay, and then I am giving here plt dot tight layout. And what is this plt dot tight layout? If you don't know, then you can go and Google it from here. Plt dot tight layout, it will show you everything, like it will adjust the padding between and around subplots, just for visualization and just to see the result in better way. We are using these things. Okay, so this thing we are passing. If you are not giving this, then also fine. Plt dot show I will do. Okay, then we will get our result. Okay, so this is our function which will plot Melspectrogram by taking this y and sampling rate. Okay, let me plot some Melspectrogram. I'm using this audio again. Okay, I will load this this thing. Okay, to see the visualization. So this is y and SR we will get from here, and then what I will do, I will call this function here directly. Okay, y and sampling rate I am giving this one. Okay, run this. So you will get this Melspectrogram. Okay, and this color bar which we have done here, if I comment this and run this, then you will see the difference. You will not get that vertical line. So that color bar represent basically that thing. Okay, if we do that, then we will get this color, so that we can understand that okay, from here in this part, if you go in this color, it's around minus 50 dB. Okay, if something is white, like here light colors, so for light colors the values are near to zero. So that's what we can understood by seeing this color bar. Okay, just for representation we are doing this, but when we are going to feed this entire thing to neural network, then we will not feed this color bar, we will only feed this graph. That is enough for our convolutional neural network to understand that okay, so blues audio Melspectrogram is something like this, so it will try to find some pattern or insight from it. Okay, no need to give this thing there. Okay, so this is the representation of Melspectrogram of entire audio. Okay, now what we will do, this audio representation is this one. Okay, so if I feed this entire this 30-second audio to the neural network, then it's very hard for the model to understand, to grasp the insight from it, because lots of things are there in this 30-second audio. So how our model will be able to take the insight from it? It's very hard. And then if we do this thing like this, then definitely our model accuracy will be below 70%. Okay, so we are not going to do this. So we will use the chunks Melspectrogram to do that, because in chunks Melspectrogram only we are focusing on this 4-second audio. We are not seeing the entire thing. 4-second audio representation in Melspectrogram is like we can easily represent that in Melspectrogram, and our feature also will not get lost, and our model will also grasp the feature from it. But in this 30-second audio, it's very hard for our model to take the insight from it. Okay, so that's why we will not go with this approach, but still we will compare this 4-second or like this chunks Melspectrogram with this. So this is how we can visualize the entire audio signal. We can build a Melspectrogram of this entire audio signal. Now what we will do, we will make a Melspectrogram of chunks. Okay, so same thing we will do here. We will write one function, plot Melspectrogram, and here I will write chunks, and here I will give y and sampling rate. Same thing we will do. And here what I will do, here I will write this entire thing. So I am not going to write this entire thing, I will use this thing from here. So from this chunks part, I will take this entire thing. And I will make some changes in this. Okay, so what I am going to do, I am copy pasting here. Okay, let me give here tab. Okay, so this is how what we are going to do here. We have defined our chunk duration, chunk overlap, and this samples we are multiplying by sampling rate. We are getting the chunk sample and overlap sample, and here we are calculating the number of chunks. The same thing we will do, and here we are iterating over chunks, and this thing start and end indices of that y we are calculating, and then we are feeding this to y start. Same good. And after that we will not write this thing here. Okay, we will not write this thing, and after that, like we got our y. Okay, and we also have our sampling rate will be same. Okay, after that what we will do, we will pass this new y, which is this chunk, to this function librosa.feature.melspectrogram. This now this y, our y become here chunk. Okay, so we'll use that function and we'll calculate the Melspectrogram. So what we will do, we will write here Melspectrogram. I'm writing here. So here I will write here Melspectrogram, and in this what I will write librosa dot feature dot Melspectrogram. Okay, inside this y value I will pass as my chunk. This is my new y. Okay, and sampling rate will be same. Okay, sampling rate will be same, and then I will visualize this Melspectrogram. Visualize the spectrogram. Visualization part is same as previous one. This thing I will copy paste from here. This visualize Melspectrogram is same as this thing. Okay, so I will copy paste this entire thing here. Okay, so it will take this Melspectrogram now. We'll visualize this Melspectrogram, and before that we have to do that dB part also. So this thing we have to use. Okay, so before this we have to use this dB part also. Okay, so here let me change this to spectrogram. Whatever we have done here, the same thing we are doing here. We are calculating that spectrogram, we are passing that spectrogram here, and we are calculating Mel scale, and then we are passing that spectrogram dB and sampling rate. Same thing we are doing, but now this thing we are doing for each chunk. Okay, that's it. Only the difference is that we are passing this chunk here. That's it. That's the difference. Here we are taking the entire thing, because we are focusing to take entire audio, but here we are converting those audios into chunks, 4-second chunks with 2-second overlap, and we are computing the Melspectrogram for each chunk. Okay, that's it. Run this. Okay, we have run successfully, and now I will use the same thing there also. I will use the same thing here also, and I will use this function. I will run this function here, plot Melspectrogram chunks for this entire audio. Okay, once I run this, then you will get the separate Melspectrogram. Okay, we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 Melspectrogram we are getting. Okay, so this is how we can plot the Melspectrogram. Only modification we have done, that first what we have done, we have taken this function, and this function, how we have constructed this entire piece of code, we have discussed in detail in last video. Okay, so if you don't know, then you can go and watch that video, you will understand. So we have taken that function and we have done some modification here, and we are able to get this thing. Okay, so this is what this is the result which we are getting. Okay, so we have successfully completed the visualization of Melspectrogram for the entire audio, and also we have learned how to compute the Melspectrogram for chunks of audio. Okay, so this is the very crucial steps. So these two steps are very important. So we have completed this. Now in the next video, what we will do, in next video we will perform a data pre-processing on entire audio. Like here we are testing on this one audio. Now in next video what we will do, we will take this entire folder. Okay, and we will iterate through each folder, and we will take all the audio files present in this data set, and we will build the Melspectrogram for entire data set. Okay, so that thing we will use, but before that it's important for you all to understand that what is the difference, why we are using chunks, why we are not using these things. Okay, let me, here I think I've done wrong. Okay, so to show you the difference, that why chunking is important, that's why I plotted this Melspectrogram for this entire audio. So here if you see, this 30-second audio is got represented on this Melspectrogram. Okay, and here for all 4-second, if you see, something is different. Like here for 4-second, this thing is variation, and this variation is for next 4-second, and this is for next 4-second. So this is the variation which we are capturing. Okay, so it's very hard to represent entire 30-second in single graph, but as compared to this, it's easy to represent the 4-second on the one graph. Okay, so that's why we are representing this 4-second and we are chunking it, and also we are retaining the previous information by considering the 2-second overlap here, so that we don't lose the previous information. Our model is able to understand that, okay, so this 2-second part is from previous one. Okay, so this is a continuation of this thing. So to train our model, it's important to give these things. So that's why we have done this. So that's why this that part 1 of data pre-processing, in which we have done the chunking and the visualization, and this is the part 2 in which we have seen the difference between the Melspectrogram of entire audio and the Melspectrogram of these chunks of audio. Okay, so these two experiment is very important to move forward. If I directly show you the how we can perform the data pre-processing directly by writing that entire piece of code, then it's very hard for you all to understand that exactly how things are happening. So that's why these two experiments are very important. These two are experiments. This thing is also a part of experiment, and this second is also a part of experiment. That but the third video of the data pre-processing, which I'm going to show you in the next part. So in the next video, it's very crucial, and it is the combination of this entire thing what we have discussed in part 1 and part 2 of data pre-processing. So we will combine the both things, and we will implement and we will construct one single function, which will be a load and pre-process data function. We will construct one function, and it will take this entire directory, this entire data set and directory it will take, and it will also take the class names, and then that function will calculate the Melspectrogram, and also it will calculate the respective labels. So from after that function will return and give us x value, which is our feature which we are going to feed to the neural network, and y values, which will be our label. So once we got that our x and y, then we will feed that information to the neural network, and we will try to make a classifier by using that x and y. Okay, so that thing we are going to, that data pre-processing part we are going to perform in the next video. So that's all for this video. I hope you understand that why we are doing chunking of the audio and why it is important, why we can't use directly this entire audio. These things, I think you now you are able to understand this entire thing. So that's all for this video. We'll meet in next video. Thank you guys. Thanks a lot for watching this video.